Okay, for Project 5, we'll be looking at a whale identification project. This is based on a Kaggle challenge. It's actually been repeated a couple times. The most recent one just finished up about a month ago here in this humpback whale identification thing. So I'm going to have you read about this and summarize it. So rather than me summarize it, I'm going to have you write a summary of it in your own words. So you're supposed to read about the Kaggle challenge and put the summary here. Why are we doing this? What are humpback whales? What are the images? Who's interested in this? Maybe how it scored, or what are you actually trying to do with these whale images of whale tails? So again, summarize that here. Um, this is kind of an open-ended challenge, so I'm setting you a basic framework here, which you will have to modify based on our past one. So again, we import our libraries here like we normally do. I also have the whale data on GitHub, and you can download that here, and this will bring it into this collab, and it'll show up in your files as CIS 3115 whales, and there'll be both a training and a validation. Now the whale challenge is actually quite hard because there's quite a few whales in it, and some of them have very few images, maybe just one or two images of the whales, and that makes it very challenging to do. So to make it easier on you, I've limited it to the top 200 whales here, the whales that have the most images here. So you have 200 whales, and I have separate validation stuff. To actually get this to work, you have to, with Kaggle, you have to submit one in here, and this submission and stuff is a little more complicated. So we're not going to necessarily have you do that. So I have a smaller validation set here I'll have you work with. So I want you to report your training and your validation data on here. So one of the challenges, the main challenge here, is to figure out what kind of network you want. You will actually have to use a deep neural network with many layers to get this to work well. The images start out at 256 by 256 pixels, generally in color. And there's a number of architectures that I want you to look at for this. This lists some of the general architectures out here. We'll take a quick look at some of them here. So VGG is what I'm going to do is give you a quick summary here, and then I'll have another discussion with more details on these. So VGG is a kind of standard network that was developed around 2014. Again, we start with an image. Their original values were images were 224 by 224 by 3. So if you use the VGJ, you may want to consider resizing your images to that size. But then they have these are convolutional layers. They have 3 convolutional layers here, each with 64 filters. Then they have a max pooling, which drops the size down in half, and then they do 3 more layers again with 128 filters, and they drop it down in half, drop it down in half. So I have this, and then they eventually do the categorization here. And this is a typical feed-forward network, sequential like we've done before. So it's a pretty good network to be able to implement for this if you're looking for a good starting point. But in recent, so that, again, that was started in 2014, 2015. We saw ResNet. One of the problems with these bigger networks, when you get like 50 or more layers here, is the training gets harder to do, and as you train backwards in the network, some things get lost. So ResNet was developed as a way around that. So the idea of ResNet is that, again, if you have 20 layers, it was okay, but as you went up to like 56 layers, it actually performed worse. So the question was, why? How was that? And the idea is that you might have these couple layers, and what they would do is they'd have an extra connection around a couple of the convolutional layers of the network that would kind of let the training information flow backwards through the layers a little better. So where you might have, like, here's the VGG19 network, where again we have these convolutional layers just feeding forward here. With ResNet, every other layer they had an extra connection jumping around these stuff. So this can created a non-sequential network where some layers were not always just connected to the layer below them for this. Similarly, Google developed something called Google LENet, or sometimes, or now often called Inception, and there's different versions, version 1, 2, 3, for that. And that was even more complicated in some ways. So rather than having a single convolutional network, they have multiple ones. So, for example, in our network, usually you had one layer just connected through like a 3 by 3 convolution to the next layer. But what they did is they have the previous layer connected to three different types of convolutions: a 1 by 1 convolution, a 3 by 3 convolution, and a 5 by 5 convolution, and then this special max pooling layer here. And in fact, in the standard model, they do a number of 1 by 1 convolutions here to do this. So rather than just having one convolutional layer, they have 1, 2, 3, 4, 5, 6, 7 layers set up. So every layer is replaced by these 7 convolutional layers, and so we have this branching out to these, and then these combining at the end of each layer. So again, it's a very non-sequential model also. So one of the things that requires is that if you use some of those models, you have to use this non-sequential model. It's called a functional model in Keras. And what we do is we specify in a normal model, here, let's go back to this. In our normal model, we would say, here's a layer, and here's the next layer. And it is just assumed that this layer is connected to the layer before, and that layer is connected to the layer before. It's sequential. And so at the beginning, we say it's a sequential model, and each layer is automatically connected. So in the functional model, we give each layer a name, and then we specify inside here what layer each layer is connected to, and if it's connected to multiple layers, which layers it's connected to. So this is just a quick overview of that. It talks about the sequential model here, but this is the functional model and how we set things up. And so we will create like an input layer and give it some name, like visible, and we create another layer, like this is a dense layer, and we will also specify where it gets its input. It gets its input from this layer. And then again, if we have another layer after that, we can create that. So we can define these layers where we give each layer a name, and we use that name as the output or input to these different models. So we'll see some of those example setup. So your job is to look at some of these more, well, you can create your own deep neural network with just multiple layers. VGG is a good one to look at, a nice sequential one, but again, there's these combinations, ResNet and Google. The current ones Google has is this combination of the Google Inception and the ResNet combinations are out there. They're doing well, and so here's some information about those. If you want to see some sample code, this is posting on Kaggle of some sample code doing VGG, ResNet, and Inception. And I certainly encourage you to post some of your network configurations here to the discussion area. Just post the whole Python code. So redo this code to implement one of the networks and post that code to our discussion areas so that other people can see and we can talk about how this works, so we don't have to reset up all of these networks in different ways. And I'll post some beginning networks to the discussion area also to get us started. Okay, so your job is to do that. Next, you can look and see if you want to fine tune any of the parameters that we have here. So your next task, decide, do you want to do any image augmentation? I should double click there. Okay, image augmentation. Do you want to work on the learning rate or learning rate reduction? You want to change the image size or a number of epochs? And so again, we just have our basic network here, and you're free to change any of this stuff. So we have some learning rate reduction information here. We also have some learning stopping here that are set up. You can change that. This just reads the data from the folders, so you probably want to keep that. And you should see, and here's our image generators. And again, right now we're rescaling these and we're doing horizontal flips, but we're doing anything else, so you can consider adding those. We don't have that many images of whales, so that might be actually useful in this place. Here we're reading from directories, and here is where we're setting the size. Not all the whale images are the same size, so we're resizing them all to 256 by 256 as we process them. There are only 2,700 images for training and 900 for validation, so we don't have that many images of the whales. Here's our network training, and again, you can decide how many epochs, how many images for each epoch, and how many epochs to go through here to set this up. Now, you have to watch. It's hard to set this up initially, so this is just our basic network, and this will not be deep enough to do the training that we want. If I look at the accuracy, it starts at 6%, and I train it for a long time, and I get all the way up to 8%, which is really bad. So again, and even my validation is even worse. It's less than 2% on my validation. So that's after 50 epochs, 200 images per epoch. So you want to work with that. If you have a deeper network, here, let me see. Let me jump over here. Here's a deeper network I've been training. I've been doing this 41 images per step or epoch, and I did this for 200 epochs. But this is much better. This is actually my accuracy down here in this version. So again, for a long time it did not increase, but then it finally started learning and increasing and got up to around 70%. So if you can get up to 70% on this whale stuff, that's really good. So that's what we want to see. We want to see this increasing like that. Where if I look here, my accuracy, it did not get anywhere near 70%. It stayed way down here. And in fact, my loss, especially my testing loss, went way up here. So this network you're given with to start with is very poor. One other thing to watch, you can watch for when you're reporting these networks, is the number of parameters in them. Like I say, you'll need a deeper network. So this one just has so many layers, and one thing we watch is the number of parameters here. So this has 8 million trainable parameters. So you can kind of watch that. So when you report your networks and stuff, make sure you report what that is. I have you ask for the total number of parameters here, and then the number of layers and stuff like that. Okay, so figure out how you're going to train it. Try the different training things, and then again at the end, I want you to report your results. You probably have to try a couple attempts. So in this area, you should keep track of your attempts here as you go. And also post to the discussion area, share your results so that others can see and learn from those there. So good luck. This is a challenging problem. And again, this is some of the cutting edge, you know, image recognition stuff that's going on right now. So you get to play with some fun networks. Feel free to use the discussion area to post questions and ask for assistance if you feel need. And I'll post like an initial VGG and a couple other networks there to get you started. Good luck.